Right, thank you. So yeah, I've been working at CEA for about 4 years now. So CEA is a French research institute, and parts of our research is based on physics simulations. And so we maintain a few HPC clusters, and we also have quite a few Lustre file systems behind those clusters. And to manage those Lustre file systems, we use a policy engine called Robinhood. And so before starting to talk about Robinhood 4, I thought it would be interesting to do a sort of overview of Robinhood's history and how we use policy engines at CEA. So CEA started using policy engines since 1999. The first policy engines were storing the metadata in memory, and they were used to run only purge policies. The first version of Robinhood came in 2005. It was the first version that was OST aware, so it was used to basically remove files to avoid OSTs to become full, still in memory. And then with Robinhood 2 came the first implementation of an external copy of the metadata in a database. And it also supported a few more types of policies. But those policies were still hard-coded. And so with Robinhood 3, so Robinhood 3 is the version that most people are familiar with. So it's a very flexible version of Robinhood that lets you create custom policies, so you can either implement your own modules in C that would let you add custom behaviors to Robinhood, or you can also implement policies using basic shell scripts as well. And in 2018, they started to think about improving upon Robinhood 3 and having more flexibility and also improve the scalability of Robinhood 3. So before diving into Robinhood 4, we've released this year a new version of Robinhood 3, so 3.2 that Aurélien talked about yesterday. The main sort of addition to Robinhood 3 was the support for project IDs. And this was actually a feature that was contributed by Stéphane Thiel, so this is a Stanford contribution. But we also support more recent OSes and also a little bit better support for 2.15. So why Robinhood 4? So as I said, one of the concerns with Robinhood 3 was the scalability of the MariaDB database. For those of you who use Robinhood 3, when you have more than a few hundred million inodes in your file system, you can start to see that the database becomes quite slow. It can take between 10 to 30 minutes to run some queries on the database, which is very limiting. For instance, if you want to do custom reports on subdirectories and things like that, it can become very, very slow. So they wanted to use more scalable databases. At the time, they chose MongoDB. And the idea was to have something that is more modular, where you could implement, or you could essentially use Robinhood in very different ways, depending on what you want to achieve. And we'll see that later. In Robinhood 4, you have basically a dedicated tool for each use case. You don't have a sort of centralized policy engine as in Robinhood 3. And since we've basically restarted from scratch, we've also taken the opportunity to support more modern Lustre features. So we support FLR, data on MDT, progressive file layouts, and also more recent versions of DNE as well. But the main architecture of Robinhood hasn't changed much. We still mirror all of the metadata in a database, and then use that database as a basis to run policies and create reports on the file system usage, essentially. So a few core concepts before I'll show you the Robinhood in action. So most of Robinhood's tool deal with something we call FS entries. So an FS entry is essentially just an inode with all of its associated metadata. So you have all of the regular stats, such as the access time, change time. You have also the extended attributes, and we also have extensions that I'll talk about a bit later, which enable you to add specific metadata, for instance, luster-specific info. And then those FS entries are stored in what we call backends, and we have different kinds of backend. We have the sort of read-only backend from which you would pull the FS entries. So we have the file system backend, so we support essentially any POSIX-compatible file system. And we also have extensions specific to Luster, and we also use, or at least support, the MPI file utils library that I'll show a bit later. Robinhood 4 is also flexible enough to support object store kinds of storage systems. So we support one object store called Hestia, which was developed under the IOC Euro HPC project. And we also have the database kind of backends. So obviously MongoDB. There's also a work in progress to add support for SQLite, and again, something about MPI file utils. And as you can see below on the slide, so Robinhood tools use something we call URI to identify entries inside of a backend. So in the first example, you can see we are specifying a subdirectory named Scratch under the file system mounted at /mnt/luster, and it's using the Luster backend. So it will fetch all of the regular POSIX metadata plus additional Luster-specific metadata. And then the second backend on the left identifies a MongoDB collection named myfsdb in this example. And the third example is a way to identify a single FS entry in the Mongo collection. So in this example, it's done using the FID of the entry we want to look at. So these are sort of the URIs are used in most of the Robinhood tools, as you'll see later. So looking at file system backends, so the way they work is that you have a basic POSIX backend that will simply traverse the file system and fetch the metadata of each entry in that file system. And then you can add extensions to that POSIX backend to fetch extra information. So for instance, the Luster extension will fetch the layout of the file, the HSM attributes, and all of those. We also have a retention extension that I'll talk at the end of the presentation, and an MPI file util extension that lets you use MPI file util semantics to traverse the file system in a distributed fashion. So let's look at a few examples. So first of all, we have a tool named RBH Sync, which lets you synchronize the metadata between two backends. So this is the scan part of Robinhood. So you specify the source of your FS entries, which will usually be a file system type backend, and the destination, which will be a database kind of backend. So in the first example, I'm synchronizing all of the metadata of the file system. In the second example, only a subdirectory. And this, in the third one, only a single file on the backend. So then we have RBH Find, which lets you query the database backends. So RBH Find only works on database backends, because if you want to use it on the file system backend, you already have tools available like the regular find or even LFS find on Luster. So as you can, contrary to Robinhood 3, in Robinhood 4, RBH Find is much closer to the implementation of the regular find. So we support a lot of the specific syntax that you can see on the last example. And again, as I've shown earlier, you can specify a single FS entry. You can use things like printf if you want to display specific info about the FS entries you're interested in. And we currently support most of the filters that Fine has. There's a few that we don't yet support, but we sort of add them as we go. And we also have a Lustre-aware version of RBH Find, which has it supports all of the features of RBH Find plus a few additional Lustre-specific filters. So I've put a few here, so the HSM state, the OST indexes, the pool names, for instance. So one of the latest additions to Robinhood 4 is the RBH report command. So this is a command that already exists in Robinhood 3. The version 4 implementation is a little bit more generic, so you can essentially create any custom report you want. In this example, so you can specify on which fields you want to group your entries in your reports. So in this example, I first group entries by type, and then I can create also buckets per file sizes. And then you specify also which statistics you want to compute on your FS entries. So you can display the count or averages and things like that. What you can do, for instance, is create reports with files that haven't been modified for 1 year or 6 months or things like this. This is the first version of RBH report, which essentially recomputes everything each time you want to create a report. In Robinhood 3, there's a lot of pre-computation that happens behind the scenes so that the reports are generated much faster. So on a real database with a lot of inodes, this can be very slow. So the futures versions will also pre-compute parts of that info so that the reports are generated faster. So then we also support changelogs. So the command is RBH FS events. So the syntax is a bit weird, but essentially what this command does is that it will read the Lustre changelogs from a single MDT that you specify in the source, and it will store it will use the file system mount points given as an argument to enrich the changelogs, so fetching, the Lustre layout, for instance, if there's been a change on the file, and also you specify the changelog user, which is necessary to acknowledge that, to indicate to Lustre basically that the changelogs have been read and that Lustre can discard them later. And so once RBHFS event has processed the changelogs that I've shown in this example, the entry is stored in the database. So then we have MPI file utils support. So this is done in sort of two ways. The first thing is that we've integrated the scan API of MPI file utils to essentially do distributed scans using RBH sync. So using the Lustre-MPI backend, you can essentially create a job that will traverse the file system in a distributed fashion and then store all of the metadata in the MongoDB backend. And then what we've also done, so you may be familiar with this, but in MPI file utils, you can generate files. So you can use, for instance, dwalk or defined to traverse a file system, and then ask MPI file utils to generate a file, and that file will contain essentially all of the entries that were scanned by MPI file utils. And so what we've done in Robinhood is that we have an MPI file backend that is able to read those files, and so you can do pretty much anything you want with it. You can copy the content of the file into the MongoDB backend, for instance. You can also use RBH find on those files. One of the limitations of this is that the file type doesn't support all of the features of Robinhood. So for instance, you don't have the HSM states in those files, so you cannot use the HSM filters of RBH find. And also what you can do is create one of those files from the MongoDB backend, for instance, so that you can take the mirror of your metadata, generate a file, and then use MPI file utils tool to run custom commands. So in this example, I've used define, but you can also use DRM if you want to remove files in a purge policy, for instance. And one of the goals is also to be able to generate those files using RBH find so that you can create essentially any, you can reduce the amount of, you can query which entries you're interested in, generate a file, and then run an MPI file utils command on those files. And then, so we have the retention feature. So this is a feature that was driven by our users. What they wanted was a way of indicating to us when we can remove their files. Some of our users deal with a lot of files and they don't necessarily always remember if their file is still useful or not. And so with this, we can automatically remove files once they decide that they don't need them anymore. And the way it works is that they will store a timestamp in an extended attribute, and then Robinhood will read that timestamp and store that in the database. And then, as you can see, using RBH find, you can display the expiration date of your file. For instance, you can also display all of the expired files, and if you want, you can even remove all the files that have expired on the back end. What we also support with this feature is to store this extended attribute on a directory so that the user only sets the expiration date once on the directory, and then all of the files in that directory are removed when the expiration date is reached. And we also support a relative expiration date where the user can say, okay, I want to remove this file 30 days after the last modification or the last access, for instance. And so this would work also for directories. So if any file in the directory is accessed, then we won't touch any of the files in the subdirectory. But if none of the files have been accessed for a month, for instance, we can remove the directory entirely. Right, so these are most of the features that are currently supported in Robinhood 4. So as you can see, contrary to Robinhood 3, we don't have a policy engine yet. So if you want to implement, if you want to use Robinhood 4 and implement some of your policies with it, you would have to compose those tools to implement basically the features you want. So for instance, using RBH find, you can list all the files that haven't been accessed for months and then remove them if you want to. So what we'll be doing this year on Robinhood 4 is focus on deploying it internally. So what we'll be doing is a lot of optimizations and benchmarks as well. We've done a few benchmarks in the past, especially for the MPI file util scan. We've been able to reach with MongoDB something like 30,000 inodes per second during the scan phase. But we also need to do benchmarks on RBH FS events, for example, how much FS events, how much change logs we can read per second. And also we have to optimize RBH report as well. There's also a few tools that we will be developing this year. So there's RBH undelete, which is sort of related to the feature that Andreas was talking about undeleting files in Lustre. So the idea is that from time to time, some of our users have a tendency to delete their files by accident. And what RBH undelete does is that we can recreate those files using the metadata from Robinhood and the content from the HSM archive. And so this is one of the tools that already exists in version 3, but we will port to version 4. There's also the garbage collection. So if you're using changelog, this is an issue that you might not run too much into, but The idea is that from time to time you might miss some change logs or be too slow to treat all of your change logs, and you might have stale entries in your backend, in your database. And so the garbage collection is essentially the ability to remove the entries that have been removed from Lustre but are still in your database. And we've also started discussing about having an actual policy engine in Robinhood 4 so that you could translate your version 3 configuration to version 4, and you wouldn't have to re-implement all of the policies that you have currently. So I think that's it for me. So obviously Robinhood is open source and you can contribute if you're interested. If you have issues, you can also open issues on GitHub, and we also use Garrett for reviews. So if you contribute, this is where you would push your changes. So if you have questions.
Questions for Guillaume? I have one actually. You know, to replace policies, right now you run those commands, you know,
Yeah.
and today with policies in V3, you run your policy, and while it's finding results, you know, and entries that matches the policy constraints, it will start processing, you know, the rules, the policy rules. In V4, do you have to wait to get the full list of the result of RBH find before, or can you pipe that and have a partial?
The way the RBH find version on V4 is a bit better than version 3 because so we iterate through the results of the database. So you get the results as they arrive on the client, and we display them as we have them. So if you pipe, for instance, the output of RBH find, you would progressively get your.
That's what I wanted to know. So you can pipe commands and start to like HSM archive.
Yeah.
Do we have any other questions?
Okay, thank you, Guillaume.
Thank you very much.